to the joint B. I know that the joint B, from my equation, sum of Fx and sum of Fy, I know from these two equations that the forces exerted on joint B is 707 Newton towards B and 500 Newton out from B. So what I will do to continue the solution, because I still have this member right here, okay? So what I will do, guys, I will draw the opposite forces in each member, so that, because I know they are internal, so they will be cancelled out. So this is 707 now. Okay, so the opposite one is this one. This will be 707. Okay, so I take the completely opposite force. Okay, so it is towards C also. Now, since this is 500 Newton, then the opposite one in this member will be this one, and this will be 500 Newton. So please forget about the members, and let's focus to the method in order to solve such problems. Okay? So guys, here, I know that B is done. So what do you think, guys? What is the easiest joint now? Is it A or C? If I take A, I still have 1, 2, 3 unknowns. Okay, AY, AX, and the internal force inside AC. So I cannot solve for A. If I take C, now here, guys, I only have one unknown, which is inside AC. Which means, guys, I can solve for this unknown. Okay, if I take C, I will have two unknowns, CY and the internal force inside AC. So the second step is to take what? Take my joint C. What are the forces exerted on C? The forces basically exerted on C are 707 CY and this internal force. And as I said, guys, I will always take the unknown out from the joint. This is my method. Now you can take it into the joint. But I advise you guys to do this, because whenever you put in your mind that you will always take the assumed internal force out, then if the answer is negative, you know that it should be N. Okay? So this is my free body diagram for joint C, and now I will apply these two equations. So let's start by sum of Fx is equal to 0, and you can call this FCA or FAC, it is the same. Sum of Fx is equal to 0 will give me what? Minus FCA plus 707 cosine 45, okay, is equal to 0, so I can find FCA, and FCA is here positive. So FCA will be equal to 700 Newton. Okay, now what about CY? CY is positive, minus 707 sine 45 is equal to 0, and this means that CY is also equal to 500 Newton, and it is also positive. So they have the correct directions. So what I want to do basically is to draw these correct directions here. So these are the forces exerted on the joint C. This is 500, and now this CY is 500, and of course this will be opposite to what? To this 500. And then, guys, I can solve for joint A because I only have two unknowns. So let's solve for joint A. Now at A, I have the reactions AY and AX. I have this 500 Newton, which is FAC, which is basically the internal force inside the member AC, and I have another 500 Newton. So as you can see, it is very trivial, and this means that AY should be downward, and it is equal to 500, and AX will be to the left, and it is equal to 500. Okay, so guys, if the question is only to find the internal forces, don't waste your time in finding the reaction. Okay? So if the question is only to find the internal forces, I don't have to find the reactions at A and the CY, because in fact they are external. I should only find FBC, FCA, and FAB. Now the second part of the question is to find if the members are in compression or in tension. Let's do it. As I promised you guys, I will give you a very easy method to know directly if they are in compression or in tension. Basically, if the joint is in compression, so the force is into the joint, then the member BC will also be in compression because I have an action-reaction. So this force here is subjected to B from BC. So B will react with this force. Okay, so I will put the reaction of B in dashed line with this force and the same for C, which means these two forces that are basically the internal force for BC. So this is BC. These two forces means that BC is in compression, and as I said, guys, you can directly predict this from the beam, from the joint B. Now the joint B here in the member AB is subjected to tension, which means that you can say directly that AB will be subjected also to tension. Okay, so action-reaction, so this is 500, 500. Now, the joint C in AC, so I will put C here. The joint C in AC is subjected to tension, which means that the member AC will be subjected to tension. Okay, so you take the joint in this member, is it subjected to compression? Then the member will be subjected to compression. The same joint could be subjected to tension in another member. So you take the same joint in the second member. If it is subjected to, like in this case, AB, it is subjected to tension, then AB will be subjected to tension. So basically, AB is in tension and AC is in tension also. Okay, and as I explained to you guys, this is because the action and reaction, basically the joint B is subjected to this force from the member BC, so it will react by this force, and this force is basically a compression for the member BC. Let's solve the second problem. Okay, so guys, this is the second problem. Basically, it is the third. The second is very easy, so you can solve it by yourself. So this is the third problem in this chapter, truss method of joints. And in this problem, guys, I have the same question, and it is to find the internal forces and state whether they are in tension or the members are in compression. Now, if I take a look to this figure right here, I have some geometrical answers. So basically, using the mid theorem, I know that this is 1 meter. Okay, because this is the midpoint of DA and this is the midpoint of DB. And basically, if this is 1 and this is 2, then I can find this angle right here. Sorry, 10 minus 1 of 1 over 2, which is about 26.6. Okay, so guys, now I can start by the steps to find out the internal forces. Now, what do you think, guys? How I can start? First of all, let's put my reactions. Now here I have 2 reactions because this is a pen, and also I have 2 reactions here because this is also a pen. So I will put now Bx in this direction. So this is Bx, this is Ax, this is Ay, and this is By. I'm sure that this is a truss because in fact the members are only subjected to forces on the joints. Okay, so there's no external force on the member itself. All the forces are on the joints, and I need to apply the equation of equilibrium. How to start? I should choose one joint. So what do you think, guys? What will be the joint that has a maximum of number of unknowns of 2? Basically, if I take A, I have 1, 2, 3. Okay, so because I have this internal force in the member AE, AX, and AY. If I take B, I have 1, 2, 3, 4. Okay, I have 2 members, okay, pinned at B. So 1, 2, that are the reactions, and this force with this force, so they are 4. If I take D, basically, I only have 2 unknowns because this force here is known. So I can start by D. Now what about C? I have 3 unknowns because I have 3 members. But about E, I have 1, 2, 3, 4 unknowns. So I should start basically by D. So let's draw the free body diagram of D. Now basically guys, D has one external force which is 600 Newton. It has one vertical force. So as I said, I will always assume that these forces are out from the joint. Okay, so as if they are in tension. Okay, so this will be called FDE, and then this force right here that will be called FDC, and the angle is equal to 26.6. Okay, so guys, now since I only have two unknowns and I have two equilibrium equations, sum of fx is equal to 0, sum of y is equal to 0, I can find these two forces. Remember guys, I know from the previous chapter that I still have another equation in 2D, which is the sum of moments is equal to 0. Yes, you're right, but in fact, the sum of moments is equal to 0 will give me a trivial equation here, because in fact, I'm doing the free body diagram of one point. So if I do the sum of moments around D, this will give me 0 is equal to 0. So that's why there is no here another third equation. I only have these two equations. Okay, so basically guys, let's start by the first equation, which is sum of x is equal to 0. Okay, so sum of x is equal to 0 will give me FDC sine 26.6 plus 600 is equal to 0, so I can find FDC. So FDC is equal to 600 minus 600 over sine of 26.6, 42 Newton in the negative side. So basically, since FDC is negative, this means that this is not the correct, it is a wrong direction, and I can translate this here to my clean figure, and then I can put this FDC here. So this is the correct direction of this FDC, and remember guys, this FDC is the force exerted by the member DC on the joint D. Now this is in compression, and I can directly say that DC, member DC will be also in compression. Okay, now what about FDE? What do you think guys? FDE in the negative y minus, so guys, I will be restricted now to this direction, okay? Minus FDC cosine 26 is equal to 0, which means FDE is equal to minus FDC cosine 26. Now FDC is negative, okay, so it is minus minus plus 1342 cosine 26, which is basically equal to plus 1200 Newton, which means guys that the downward direction of FDE was correct. And then I can put it here in my clean figure. So this is FDE. Guys, I can say that this is equal to 1342 and this is equal to 1200. And this is the correct direction of this force. And since this force is in tension, then the member DE is also in tension. Now guys, I can put the opposite direction for these two forces. So then guys, this is the force exerted on the joint C, and this is the force exerted on joint E. So it is tension for E and compression for C. Okay? That completely opposite force, okay? So here guys, what do you think? I should take what joint? I cannot take E, even if I know this force, okay? Because in fact, I still have 1, 2, 3 unknowns. Now for C, since I know this force now, I only have 2 unknowns. This is the first one and this is the second one. So let's take joint C.